Okay, hi there. Welcome to module number 3 of this course. So, in this module, we are talking about evaluating AI vendors. And this helps you close the information gap that often exists between the healthcare leaders and the tech vendors. Here, you will learn how to question the performance claims, evaluate the evidence, and make defensible procurement decisions. So we are here. This is lecture number 1. So we are here to talk about evaluating the AI vendors and the solutions. This module is designed to empower you, the leader, to cut through the sales pitch and truly understand what you are buying. Vendors are experts at selling AI, and they'll present their products in the best possible light. Our goal is to make you an expert at evaluating these solutions so that you make informed decisions for your organization. We will focus on closing that information asymmetry, ensuring that your decisions are grounded in solid understanding, not just good demo. This is about equipping you with the tools to ask the right questions and interpret the answers effectively. So, building on that idea of information asymmetry, we see a clear imbalance. Vendors know their products inside and out, including their challenges, including their limitations. But the presentations are crafted to build confidence and not to expose the weaknesses in their products. On the other hand, leaders like yourselves know your organizations deeply, but without a structured framework. You might rely on gut feelings or brand recognition or things like that. So that's not a defensible position when making significant AI investments. So my objective here is to provide you with the frameworks and questions needed to bridge this gap. We want to move beyond that gut feeling thing and give you a robust method for evaluating AI solutions. And this will prepare you for the specific tools we are going to use to challenge vendor claims. So, following up on the need for structured evaluation, let's talk about the demo. A sales tool is not an evidence. And that's where our demo skepticism checklist comes in. You need to ask critical questions about the data used in the demo. Was it their pristine data or your messy real world data? Did they show you how the system handles failures or edge cases, or just the perfect and happy path use cases? Also, consider the integration aspect. Was the demo truly representative or of how it would work with your specific electronic health record? We also need to push for details like beyond simple point estimates like confidence intervals for performance metrics and crucially equity breakdowns across demographic groups. If any of these boxes that you are seeing here in the slides are unchecked, that's your cue to dig deeper. This checklist helps you to move past the dazzle of a demo and into the substance of a solution, which leads us to a common problem with vendor claims. So, this is a critical issue, the curated data set problem. Vendor performance claims, while technically accurate, are often based on data that is far cleaner and more complete than what you have. Their training data is very pristine, while your operational data is messy with different demographic and electronic health record structures. This gap is where most performance shortfalls originate in the real world. To expose this gap, you must ask about the demographic composition of their training data, the specific EHR training systems, the electronic health record systems, and the data structures used, and the data completeness rates for key variables. A model that performs perfectly on their curated data might struggle significantly with your real world data. So, understanding this distinction is very vital and it leads us to the technical literacy needed to interpret the performance metrics accurately. So, to truly understand AI performance, we need to move beyond simple accuracy and grasp concepts like sensitivity and specificity. Sensitivity tells us how well the model finds actual cases. High sensitivity means fewer missed cases, but is also can lead to more false alarms. Conversely, specificity measures how well the model rules out known cases. High specificity means fewer false alarms, but you might miss more real cases. So the leadership question here is crucial. In your specific use case, which is more costly, a missed case or a false alarm? This isn't a technical detail. This is a strategic decision with clinical, operational, and ethical implications. This understanding of trade offs is essential as we consider how to apply these metrics in different contexts. So, when we talk about sensitivity and specificity, it's not about one being inherently better than the other. It's about context and your organization's less risk tolerance. We need to choose our risk profile based on the use case. For something, let's say like sepsis early warning, missing a case carries severe patient harm. So we prioritize sensitivity, even it means more false alarms. But for a no-show prediction model, false alarms create chaos in scheduling and in patient experience. So in this use case, the specificity is the key. The leadership question is what's the acceptable risk of a wrong choice for this specific application? And always ask for some specificity at the vendor's chosen sensitivity threshold. Now let's talk about why accuracy alone can be misleading. It's a common trap, especially with the base rate problem. Imagine a model predicting 30-day readmissions where the actual readmission rate is only 6%. A useless model that just predicts no for everyone would still be 94% accurate. This sounds good, but it delivers zero value. A vendor's AI driven model might have 91% accuracy, which seems worse, but its sensitivity and specificity show it's actually delivering significant value. So, the key leadership question here is what is the true base rate of the outcome in our patient population? This understanding helps us avoid being fooled by high accuracy numbers, and it leads us to consider how models are truly validated. So, understanding validation levels is also crucial for assessing a model's real world readiness. So, it's not enough for a model to work on its training data. Internal validation, which as you see here is L1, level 1, just proves that model fits the data it learned from. It's a starting point, of course, but not a proof of readiness. External validation, which is level 2, tests the model on separate retrospective data. This shows if it can generalize. But the gold standard here is prospective validation, which is level 3 and level 4, which means testing the model in live conditions, forward in time, ideally in a similar setting to yours. As leaders, we must ask for full validation report, not just a summary slide. So this helps us understand if the model is truly ready for our environment. But even with strong validation, we need to consider the data itself. So while talking of data, we need to address the training data bias. A model only learns what it is shown, and this can perpetuate existing inequities. Demographic bias means the model might underperform for certain, let's say, age, sex, or ethnic groups. Historical bias can automate past disparities in care. And setting bias means a model trained in an academic center might not work well in a community hospital. So, as leaders, we must demand transparency. We need to ask for performance data broken down by age, sex, ethnicity, and geography. This ensures our models are fair and effective for all our patients. All right, we will continue this in our next lecture.